In preparation for final examination, we have a question from section C of Science Paper 1, and this question is coming from the topic of radioactivity. So as you can see, we have strontium, so symbol SR with a mass number of 90, the atomic number of 38, is a radioactive isotope. A nucleus of strontium 90 decays by the emission of a beta particle. So we are dealing with this decaying that involved the beta particle. So for the first question, it was just to define the term isotope. Now, before we define the term isotope, I'm going to use these three atoms of carbon to explain what isotope is. So these three atoms will have the same atomic number, but we are going to have different mass number. So we have carbon 12, carbon 13, carbon 14. Now, to understand, let's find the number one. We are going to find the number of neutron in each. So I'm going to first begin by the number of neutron in the carbon 12. So to find the number of neutrons, so you get the mass number. So the mass number is 12. Then we subtract by the atomic 6. So this is giving us 6. Therefore, carbon 12 has 6 neutrons. Right. Then we move on to carbon 13. So I'm going to write N13. So number of neutrons will be 13 minus 6 is equal to 7. Therefore, we have 7 neutrons in carbon 13. So we move on to N14. So we'll say 14 minus 6. Then we have 8 neutrons in carbon 14. So from the 3 atoms of carbon, we can conclude by saying that what was different was the number of neutrons. So therefore, we can define as an isotope as the atoms of the same elements having the same atomic number but different numbers of electrons. I know we are familiar with saying it with different mass number, but what makes the mass number to differ is due to the presence of difference of the neutrons number. So the best definition here we just say these are atoms of the same element. So it can be 2, 3, as long as the atom of the same element with same atomic number. Same atomic number, but different number of neutrons. Right, so we've seen and we have at least understood what this simply means. Now we move on to question B. For a neutral atom of strontium 90, state the number of electrons, then number 2, the number of neutrons. So it's simple. Whenever the word neutral is mentioned, it simply means that the number of protons equals the number of neutrons. So I'm going to write the chemical symbol for strontium with SR. Then we have the mass number of 90. Then the atomic number of 38. So as long as as long as this atom is neutral, this 38 refers to the number of protons and also refers to the number of electrons. So to find the first answer for Roman number 1, we are just going to get this number here as long as it's neutral. So we have 38 electrons. So we are done with the number of electrons. So number 2, we need to find the number of neutrons. So we are going to use the same principle that we did to find the number of neutrons in the 3 atoms of carbon. So I'm going to say neutrons is equal to, so the key point is the mass number. You get the mass number, then you subtract by the atomic number, which is the mass number for strontium is 90. So I'm going to write my 90 here. Then the atomic number is 38. So we need to find the difference between 90 and 38. So this gives us 52. So this is our final answer. As you can see, it is very simple. Right, so we can now move on to question C. When the nucleus of strontium 90 decays, it becomes a nucleus of tritium, symbol Y. Write the equation for this decay. Now the question is, are we going to use the alpha decay, beta decay, or gamma decay? So we are going to use the beta decay. Why are we using beta decay? Because the statement says by the emission of beta decay. So this is what we are supposed to use. So now, what are we supposed to do? Right, so what we are supposed to do is, I'm going to write first the parent atom. So in our case, the parent atom is strontium. So I'm going to write SR. The mass number we have is 90. Then the atomic number is 38. Then what are we supposed to do? So what we are supposed to do is, whenever an element emits beta particle, the mass number should never change. We need to maintain the mass number. So the 90 will still remain 90. So do not do anything with the mass number. Now what of the atomic number? So the atomic number increase by 1. So 38 plus 1, we get 39. Then we have Y, since we are given this Y. Plus we need to show that it emits beta. You write the symbol E with a 0 on top, then -1. So the SR, you are not supposed to show this, but the SR represents the parent atom because it is the atom that underwent the decaying. Then the Y is called the daughter because it was what was produced. Then another thing that you are supposed to know is the mass number for strontium is 90. Then these two numbers, if you add them, you still have to get 90. So here we have 38. Even if we add 39 plus -1, we still get 38. So the numbers must be able to match. So now let's have a look at question D. So question D, we are told a sample initially contains 6.0 times 10 raised to the power 8 meters, 8 atoms of strontium 90. If the half-life of strontium 90 is 29 years, calculate the number of strontium atoms that remains in the sample after 87 years. Right, so half-life, it tells us the period taken for half of a substance to decay, or for a substance to decay by half, or for a substance to drop by half. Now, to make this question simple, I'm going to use this method here. So I'm going to say time before decaying. So before decaying, we have just put 0. So when the time was 0, how many atoms were there? So we are given this is our value. So instead of writing 6.0 times 10 raised to the power 8, I can write just this as the actual number. So this is it. So since we have raised to the power 8, it means we need 8 zeros, right? So number of atoms. So before the decaying, these were the number of atoms, which is 800 million. So what is the half-life? So remember, the half-life is 29. So after 29, 600 million will decay by half. So you get this number, then you divide by 2. 600 million, you divide by 2, you get 300 million. So we need to have another decay. So 29 plus 29. So this gives us 58. So after another 29, half must decay. So I'm going to have 150 million atoms. So remember, we are dividing by 2, or you can say, yes, we are dividing by 2. Even here, we are dividing by 2. That's what you have to do. Then let's say 58. 58 plus 29. So if we do some calculations here, we are going to have 87, which is this is the actual number. So you need to end according to the number given. So the last part is we just have to divide by 2. So 150 million atoms divided by 2, I'm going to get 75 million atoms. So which simply means that after 87 years, 75 million atoms of strontium remained. Then the rest decayed. Then we have the question E, where we are told to explain what is meant by random. So random simply means that this process of decay is not known. It's just a probability. So you can't tell when this substance will decay. No one knows when the substance, it occurs randomly. So that's what it means by random. But we just simplify our answer as these emissions occurs randomly and without any reason, which simply means it's all based on the probability. It's just a chance. It's not known when. It can happen anytime. So as you can see, this was simple. Let's hope you enjoyed it. Thank you so much.